So let's now talk about work done by frictional forces. And let's see what happens when a box slides along a tabletop. Suppose we have the following table that is a height h above the ground, and let's suppose we have a box with a mass m that travels from point A to point B. So initially it has some velocity v, and it stops at point B. So its velocity at point B is 0. And let's make the assumption that this tabletop is not frictionless. That means frictional forces do exist. Now let's look at our initial conditions. Initially, our box is traveling with some velocity v, and that means because it has some mass m, we can find the box's kinetic energy by using our formula for macro objects, for large objects such as this box. So, kinetic energy of this box equals 1/2 times mv squared. And likewise, since this box is placed above sea level, above h equals 0, since the height of this box is h, we can say that its potential energy, or gravitational potential energy, is m times g times h, where m is the mass of the box, g is our gravitational constant, and h is simply our height. And let's look at our final conditions. When our box actually stops at point B, what are our energies now? Well, now our velocity of the box at point B is 0 because our box is stationary. And that means, since our velocity is 0, our kinetic energy is also 0. What is the potential energy of the box at this point? Well, the potential energy does not change. Why? Well, because the mass doesn't change, g simply doesn't change, and h, the height, also doesn't change, right? We're assuming the tabletop is leveled. So the height at this point and this point is exactly the same. So that means our potential energy due to gravity of the box remains the same. So once again, as the box slides across our table, it begins to slow down because of the force of friction. Remember, we're not assuming this tabletop is frictionless. If we were, this box would continue moving with the same velocity. But because of the force of friction, which acts on the block in the opposite direction to the motion, that force of friction stops our box at point B. Now, when the block actually stops, its kinetic energy is now 0, which we just spoke about. But my question is the following. Where has this kinetic energy gone? In other words, we had our initial conditions and final conditions. So we had some kinetic energy and some potential energy, and our final conditions, we have the same potential energy and 0 kinetic energy. That means that our energy disappeared. Our energy was destroyed. But remember, that's not true. Energy cannot be destroyed and it cannot be created. Energy exists. It simply transforms from one form to another. That means our kinetic energy must have been transformed to some other form of energy. Now we're making the assumption that the temperature of the surroundings of the tabletop and of the box is exactly the same. And that means energy cannot be transferred due to heat. Energy is not transferred due to conduction, convection, or radiation. And that means, since the only other form of energy transfer is work, some type of work must have been done. So that means our kinetic energy must have gone into some other form of energy. But what form of energy has our kinetic energy transformed into? Well, recall that frictional forces act to transform energy into internal energy of our system. And that means, since our system is this block moving along this tabletop, all the kinetic energy must have gone into increasing the internal energy of this box. Now the internal energy is simply the sum of all the different types of energies of individual molecules and atoms found within this box. Remember, the internal energy includes both the kinetic and potential energy of the individual molecules, and that means the macro scale kinetic energy has become the micro scale kinetic energy. So we see the following equation. Initially we had the macro scale kinetic energy plus our potential energy. And our final state, we had no macro scale kinetic energy. Our object was not moving because its velocity was 0. But now we had micro scale kinetic and potential energies given by the internal energy of that system. Plus, we had the same exact U. So since these U's are the same, we could cancel these guys off, and we see that our kinetic energy has been completely transformed into the internal energy of this system of our block. Now actually, in a way, that's not quite true, because since the tabletop and our box, we're making the assumption that these guys are at the same temperature. That means that some of the friction forces also increase the kinetic energy of the tabletop. So actually, our kinetic energy of this moving object has gone into, or has been transformed into, the internal energy of both our system, the box, as well as the tabletop.